In the next three examples, we are going to practice step 3 of hypothesis testing, which is called the rejection region method. And in step 3, this is where we make a decision about the claim. And we're given a bunch of information here. We're given the test type is two-tailed. It's a z-test. We have a test statistic of 2.9. A sample size of n is equal to 50, and an alpha level of 0.05. So I'm going to draw my picture. Because it's two-tailed, our rejection region is going to be in both tails. And the rejection region in total should be equal to the alpha level, in this case 0.05. Because we're looking at it as two-tailed, the alpha level is going to have to get split in half. So this wing is going to have 0.025, and this wing is going to have 0.25. Now, to find our z critical, that's what's going to give us the cutoff point for our rejection region. Now, you want to use GeoGebra to do that, and if you forget how to do that, you can go back and look at lesson 6.1 and examples 5 through 6. That will give you a quick refresher on how to find the critical value. In this case, the critical value is going to be 1.96 and negative 1.96. Because it's two-tailed, we're looking at both sides, so we're going to say that it's plus and minus 1.96. The red area is our rejection region, so if our test statistic falls in that rejection region, we're going to say reject the null hypothesis. So looking at the right-tailed area, if our test statistic falls in there, that means that it's going to be greater than 1.96. Because it's going to fall past 1.96 to the right. On the other side, if ZT is less than negative 1.96, then it falls into the rejection region. So if this happens, we're going to say reject HO. Now let's see if it happens. So our test statistic is 2.9. If we think about graphing that on the number line, it's going to be greater than 1.96, so it's going to fall over here. So it falls in the rejection region. Here's our rejection region. It's everything greater than 1.96 or less than negative 1.96. So we're definitely going to reject the null hypothesis. All right, let's look at example 15. For the following test type, test statistics, sample size, and significance level indicate whether the null hypothesis will be rejected. So we have a left-tailed t-test. The test statistic is negative 1.85, the sample size is 16, and the alpha level is 0.01. So here's our picture. This is a left-tailed test, so our rejection region should only be on the left. We're only looking at the left tail. So I got to find, now I'm using t's because we're doing t-test. I got to find this cutoff point, which is my t critical. That's the boundary for my rejection region. So if my test statistic is less than whatever that value is, then we're going to say reject the null hypothesis. So use GeoGebra to work backwards and put in that area. Remember, the rejection region should add up to the area under the curve, and that's the alpha level. So this area is 0.01 because that's our alpha level. So go into GeoGebra and put in that you have an area of 0.01 on the left, and you should get a t critical of negative 2.6. Don't forget you have to put in your degrees of freedom. And in this case, because we have a sample size of 16, our degrees of freedom is going to be 15. It's one less than the sample size. So if my test statistic is less than negative 2.6, then that falls in that rejection region, and we would say we reject the null hypothesis. Okay, so looking at our test statistic, we have negative 1.85. Negative 1.85 is here. It's on the right side of the rejection region because negative 1.85 is bigger than negative 2.6, so it's not going to fall in that rejection region. So this here is negative 1.85. So since this doesn't happen, our test statistic is greater than negative 2.6. So we're going to say we do not reject the null hypothesis. So this is our final answer, our final decision. Okay, example 16 says, for the following test type, test statistics, sample size, and significance level indicate if the null hypothesis will be rejected. So we have a right-tailed z-test for proportions. This is going to be, oops, that's not a very good drawing. This is going to be a z-test for proportions. So we're going to have a z-critical. It's a right-tailed test. So we're going to be looking at the rejection region on the right. So we need to find our z-critical. So our rejection region is if our test statistic is greater than our critical value, which we need to find. So because this is an alpha level, oops, I meant that to be 0.01. Since our alpha level is 0.01, our area in that tail is 0.01. So you got to go into GeoGebra and work backwards and find that cutoff point so that it gives us the boundary for our rejection region. When you do that, you should find that your z-critical is 2.33. So if our test statistic is greater than 2.33, it's going to fall in that rejection region. Now, looking at our test statistic is 2.95, so it definitely falls in this area. That's definitely bigger than the 2.33, so we are definitely going to reject the null hypothesis because it does fall in the rejection region.